Kia ora koutou. First of all, just like to acknowledge that this work that I've been doing the past year has been supported by a Kalman Teacher Fellowship. I was fortunate to be granted that, which has given me the opportunity to take two courses at the University of Auckland, firstly with Lisa Dara and secondly with Caroline Yoon, both of whom have been really inspirational and given me lots and lots of opportunities to do research, and also the motivation, I guess, to try and push myself a bit harder and take things a bit more in depth than I otherwise would with a full-time teaching load. So if you're considering that, I think applications might still be open. I really recommend that you have a go at that. So if I just, oops, sorry, keep my slides working. Ko waiaho, who am I? Ko Munga Kieke te Maunga. I was born in Auckland and close to Munga Kieke, One Tree Hill. I like this view, looking out west, because I've lived a lot of my life in West Auckland. Love the hills, but also really interested in geology, and through this have got into geotechnical engineering. I was, I guess, fortunate also to be a child of two very different parents. My mother comes from the Kaipara area, so down there, the bottom left corner, you see Minisdale Chapel, just above the Kaipara Harbour. Her ancestors came from a non-conformist settlement that was in Port Albert here, and they're farming people. My father, on the other hand, comes from Belgium, so you see Antwerp Cathedral there, and he's an engineer. They met and married in Africa, of all places, and then decided to have us and set up in New Zealand. So you see there my immediate family, my wife Rosemary, daughter Miriam, son Jean-Luc. The family is important to me, but also the land, and engineering has come through my father's side. A lot of my father's side of the family are engineers. So I ended up putting these two together, spending a lot of time looking at landslides, doing some modelling in open cast mines, looking at tunnels, working on tunnels, dams, that sort of thing. Here and overseas, ended up also in Central Asia doing a little bit of tertiary teaching as well. So through that work, I've practiced modelling and become aware of the power of mathematics to allow us to make some really big and important decisions, things that make life better, safer, and give opportunity to have a better world. So this takes me to the engineering science competition, which is run every year, and there was about 270 teams this year. So some of you may have had people in your school, or you might yourself have supervised the one of these teams. So yeah, I'm aware that there's plenty of people who also have experience in this area, and possibly much more experience of running modelling in schools than I. So what I'm bringing is, I guess, three different perspectives. One is as someone who's used it in industry, used modelling. Secondly, as someone who currently I'm teaching in a Steiner school, I have the opportunity to bring quite a lot of modelling into the courses that I'm running, just because of the flexibility of the curriculum. And thirdly, as someone who's had the opportunity this year to do a bit more research with the Kalman Fellowship. So here's a typical modelling question. It's very open, not in the mathematical sense of unsolved, but open in the sense that there are multiple solutions, and There's multiple ways to view the problem and to multiple assumptions that you could make and would need to make. So just to read the question, how many airships would be required to replace the Cook Strait ferries? As usual, the question is open-ended. Interpreting it and making relevant assumptions is part of what you're judged on. Any request for clarification will be met with the response, you need to make appropriate assumptions. No help with answering the competition question may be given by your teacher or any other person. Enjoy the day. Don't forget to submit your entry by 6 p.m. Go. You've got 8 hours. So when people actually meet these, or students actually meet these types of problems, you get various responses, starting from curiosity, engagement, deep engagement and excitement, lots of interest. But you also get confusion and bewilderment, responses like, I don't understand the question. Anxiety, so this confusion can lead, if they really feel totally lost in the bottom of that learning pit, they can be disoriented and feel quite anxious about that and overwhelmed, ultimately leading in some cases to rejection of the opportunity, and things like saying it's a stupid question. So my focus for a part of what I've done this year is looking at what competencies students need to actually be able to access this sort of work, and how teachers should approach developing these competencies. So a little bit of background research, starting at the most fundamental level, it's almost the opposite of teaching by rote. Sure, we teach knowledge and skills that are needed for this type of work, but without creativity and some critical thinking, you can't assemble a coherent strategy even towards trying to solve one of these problems, let alone actually solve it. So fostering these dispositions is really important. Making good estimates is always handy, and quite often we talk about the reasonableness of a solution, and getting the sense of whether an outcome or a number that you're using, some sort of input number, is a reasonable number to use. Sound knowledge of relevant mathematics is important, and I underline relevant there because people can know a lot of things. They can actually have quite a lot of technical skill, but be reaching for an inappropriate tool, an inappropriate piece of equipment, of mathematical equipment, if you like, to solve a problem when a very simple one would do. More specifically, relating to the actual modelling cycle itself, which have various stages, we have just specifying the problem, just taking all the information you're given and filtering that for the things that are particularly important and, if you like, the key questions that need to be answered before we progress towards a solution. So that's like setting the situation up and then formulating a model, translating from the real world into the mathematical world. So creating those equations, some sorts of relationships. You might use a diagram, various graphs, and so there could be technical tools, technology tools like spreadsheets used, or even coding, those sorts of things. Then using that to find an appropriate and reliable solution. So when I say reliable, ideally there's some sort of check on that, relating back to your estimates, and making sure that your solution makes sense within the context. You could also do some sort of validation against some published information or something that you've actually tried, which is going to build your confidence that your model is giving you what you actually need it to. And lastly, pulling all this together and communicating results. There's various people have slightly different versions of this cycle, and can break down parts of this. So part C sometimes is broken into a modeling, like a solution, and then their validation stage. But essentially, yeah, this is the process that we're going to go through with students if we're doing the full modeling cycle. So looking at what research says students find particularly difficult, which is interesting. Last year's PISA results, or sorry, 22 PISA results were looked at by some researchers from University of Oxford, and they really picked up on the fact that the model formulation step was harder than the subsequent solving and communicating steps. And this is across the board, across most countries, not just New Zealand. Looking at particularly why this is, really something that's highlighted is the unstructured and open nature of the tasks themselves, requiring students to make appropriate assumptions about numerical values in particular, but also just in taking that information and focusing in on the necessary parts of it. We also cognitively, when we learn something, we link that to the context within which we learned it. And so there's this idea of situated cognition, that concepts actually need to be used or experienced in a variety of situations before we can start to ourselves transfer those. If you think of the solo taxonomy, on which a lot of our assessment is based in certainly in NCEA, we have the multi-structural level, which is typically associated with achieve. So you know a few things that are relevant. Merit is typically related with relational understandings, so you can see how these things are related. You can piece them together to solve a problem. But to transfer that to another situation and see how what you learned in one area might be used in another, that's extended abstract thinking. And, we often associate that with an excellence grade. So you might be thinking, well, if it's requiring excellence thinking, can only excellent students access this sort of work? And the short answer is no, because the relevant mathematics that they need might be as simple as looking at an additive model. So we can still do excellence type work with simple mathematics. And that's a really, really key part to being able to access problems that you would actually want to solve, rather than many of the ones that that we get presented with in textbooks, which tend to maybe be a little more contrived and unrealistic. So looking at how we actually go about all of this, Nissan Bloom suggested that there are two groups in how people have typically approached developing these competencies. Firstly, what they term the bottom-up approach, which is where you look at the various types of things that people need to be able to do in order to follow the whole cycle. And you don't try and do the whole thing at once. You just maybe focus on one or two of these skills, what they call these sub-competencies. So you might, for example, just look at how do we take information that has been given to us and exactly the information we need and turn that into an equation. And that's something typically you do at level 1, NCEA level 1 in tables, equations, and graphs. So we learned that type of process quite well. And so that could be like a 2 or 3 step lesson or sequence within which the context that you want them to explore is sort of set up for them in some way. And you can also assess these sub-competencies, if you like, that formulation stage, and whether they can input various possible realistic data into their model, and sort of play with it, explore that model, and get an understanding of how to interpret its output. So you've got a couple of the stages there. This is contrast with a top-down approach, where you simply give them a solution, a situation, and have an open question. Typically, though, what you do is focus on this. If you're really wanting to develop the overall modeling competence of being able to go through that full cycle of becoming comfortable with these open questions and knowing how to get started on them. And you could do this after working on them with a bottom-up approach. So you can sort of combine these two approaches according to the needs of your class. You can also give instructional prompts, so make those available if they are starting to to get too wide-eyed, or if they're starting to show signs of distress, or are simply obviously stuck, and you don't want to fully rescue them, but you do want to give them maybe a bit of a leg up out of that learning pit. So how would this look like if you were to graph it out? Well, typically a bottom-up approach, starting at the bottom here. You'd be thinking, what sorts of tools, what sorts of mathematical procedures, what sort of concepts do I want to introduce? Then you'd say, what's a good activity that could focus on using that tool, that concept, and just sort of limit that. So you'd be able to fit that within a lesson. Or maybe if you've got a double lesson, if you're lucky enough to have double periods, then you could extend that a little bit more and give them maybe an iteration where they would then move on to something slightly more complicated model. So they would revise their model and improve it. So you could then progress through your normal curriculum and be giving them a series of tailored tasks that were bite-sized, that fitted within a lesson, but over the course of a term, would be developing a variety of these stages of the modelling process. And together, those can be assembled at some point in the future to attack a full problem and do the full cycle. So that you're gradually building up modelling competence from the bottom, a bottom-up approach. Contrasting this with a top-down approach, in this case, you would start with quite simple, or at least situations in which you could use relatively simple mathematics, so additive or multiplicative type situations. Maybe certainly in high school, you'd be expecting them to have some proportional reasoning. So they could be, the sorts of mathematics that you would actually have to use in a business situation, but not involving anything too advanced. So you'd give them those experiences, and as you saw opportunity, you would say, oh, it looks like we need to revise our model here, but we don't have the maths yet for this. And so here's an idea, here's a new concept, here's a new procedure, here's a new tool that could help you to solve this problem or to get a more refined model, a better model. And then we use that to sort of do a just-in-time type teaching, where we have students who are already engaged, who already have got a solution, they're feeling good, they've had some success, and you're saying, do you think we could go one better? Here's some new maths that you haven't done yet. Let's see if we can understand how we'd use this in this situation. So that makes sense to students, and they want it because they want to. Everyone wants to be powerful. Everyone wants to get better at doing things, but only if they feel they can already do something. So an example of this at in Titirangi Steiner School, where I teach, we have festivals that we celebrate in the seasons. Every every season has its own festival. And for the winter festival, midwinter festival, we have lanterns. You can see some of these here. The students work on these for a term and during craft, and some of them are extremely creative. Bottom right corner there, you see a Portuguese man of war, I think. You also see some knights there, and one of them's got a battle axe, and there's a lantern inside the battle axe. Yeah, it's a wonderful evening. And it ends with a big fire, as it always should, and then baking potatoes in the fire and everyone eating together. So we've got the wider school, about 200 students, and then all the parents and families. So a lot of people there. Great evening. So this is something that they celebrate every year, and they're deeply familiar with it. It's a familiar context within which they can apply their understanding. So a problem in this case, something I've run with year 10, so year 11 students, is this question: how long will it take us to light all of the lanterns at this year's winter festival? And that's because this is part of the ritual. There's a beacon at the start, and all of the lanterns are lit ultimately from this one beacon, but it's a process where one student takes a light from that and then passes it on. So just right now, I'd like to give you the opportunity to do something that I do with students, and that's first of all to put into chat one thing you think that the answer to this question might depend on or be affected by. So let's take about a minute to just put down one thing if you can think of it. Don't feel you have to, but if you can think of something, please pop that into the chat now. Cool. We've got a number of lanterns. The weather, whether it's windy, blowtorch, but from Anne, I guess that's the question of what you're using to light them with. Yeah, how accessible the part is that needs lighting. You can see some of those lanterns are pretty complicated. See another 10 seconds or so if you've got anything you thought of. Supervision, yeah. So you're looking at all that flame, thinking, yep. Yeah, and I should say we've got everyone down to the lower school. So you've got upper school, which is high school, lower school, right down to age 5, 6. Yep. And plenty of kindy kids standing around too. All right. So I think a lot of people are thinking, as teachers, how would we supervise something in the dark? We were using lots of flame and flammable products. Yeah. This is what the students came up with. So again, how many students or lanterns there are, whether it rains or not. Typically, these festivals, the last couple have been dry, but rain affects a lot of our festivals. We still go ahead, but sometimes more accelerants are needed to light the bonfire at the end. How many of the lanterns go out and need to be relit? This is a common thing. And how long it takes to light each lantern. What they don't ask is what they already know, the system for lighting the lanterns. So I see Shabina there said how many people are lighting. So yeah, just thinking about lighting systems that might be used and what mathematical relationships would result from each of those systems. So can you please, let's just run it one more minute. What system, so think of a system that might work. So you've got one person lighting from this beacon, and then ultimately we're going to need to light around 200 lanterns. What systems could you use? Just think of one system, and what would be the mathematical relationship of how long it takes that you would need to use there? Cool. So Hui Hing has suggested that we could have one person lights first, shares with another person, and so on. So geometric progression, yep. So exponential relationship there. And then Sandra suggested that we could have a linear progression. So just one person lighting, and then does everyone's candle, or exponential, as Hui King suggested. So the actual system used is this. So we've got 200 students. The upper school students have candles. Of the 200, about 60 are upper school students. They have candles in addition to their lanterns. One student lights their candle from the beacon, and they use their candle to light another upper school student's candle. Each of those upper school students then continues lighting other upper school students' candles until all the candles have been lit. The lit candles are then used to light lanterns for upper school and lower school. So, given that system, what relationship do we have? What mathematical relationship are we going to need to use? Can you have a go at that, please, in chat?
I just check, Roland, that each senior school student just lights one other senior school student's candle.
And there you're making an assumption, but yep, the
Yeah,
situation is that they can light anyone's candle.
so they
So
could light 6 other people.
they can light as many as they can get to in the
Right,
dark.
right. Okay, thank you. Yeah,
In the
cool.
dark. So straight away there, we've got two possibilities straight away that everyone in upper school can light everyone else's candle, or that they light one other. And in both of those situations, if you've made one assumption, you get one answer, one solution, and in the other, you get a different solution. Cool. So Kerry said like a networking problem, which would be really interesting to look at the diagram for that, and suggested a shortest path problem. Cool. And in fact, this is relatively easily modeled with a combination of exponential and linear, because if you can take everyone's, so it's a sort of like a tree diagram approach, using exponential growth as until all of the upper school candles have been lit, and then you can then do a linear progression from there. But just thinking about this, is there any missing information? And if so, I'm asking, would ask students to make a reasonable estimate of this based on their past experience of winter festivals. So the big piece of missing information is how long it takes to light each candle. And, typically the students would say, well, how long does it take? And I say, how long does it take in your experience? And I invite them to role play it, and they can time each other, and come up with some sort of average number. I also, for those that are feeling a little bit that this is all really getting complicated, I say, try making it as simple as possible. start by assuming, ignoring some of that information and aim at a lower bound and upper bound. So the upper bound, the maximum time that it would take would be based on just one person going and lighting everyone's candle, which is simply multiplicative thinking. And, that's something that you could access even in primary school, and doesn't take a lot of mathematical ability, if you like. It just needs that translation from the real world into formulating that as a mathematical problem. Now, I'm going to be a bit mean here and say that I'm going to hold the actual answer as a secret, because I'll be also presenting this at the AMA Day, Maths and Calc Day, on the 22nd of November. So if you're definitely not going to be at that, then I can give you the answer, but I'm just going to keep that a little secret. So we'll be working through this fully on that day, if you're keen to come along. Some other examples, and as we go through these, you might want to consider what year levels could you use this problem with? What is the mathematics that's required, and what's the maths that could be used? Because those could be two different things. Just the required, just thinking about those rich tasks that Cami was mentioning before, the entry level, I think Cami was mentioning that entry level is the required mathematics, and the sort of exit level at top is what you could extend up to. So refining these models. Thinking about assumptions that students might need to make, or that might automatically make without thinking about it. First question, how many cats could peacefully lie on one chair? Making sure to write the question carefully. Yep, so we've got, Anne reckons only one. You're making assumptions there, Anne. Think about kittens, but this is a cat, I said. Yeah, so this is Leela, my cat, and as soon as you give this to a class, this picture to a class, you've got everyone. You've got everyone, especially the people who say, "Oh, maths is not for them." I've done this with a year 7 class, and this is just an introduction to thinking about how we use different sorts of mathematics to interpret everyday situations. Maybe two, but they need to be in love, is another possibility. So thinking about assumptions here, you've got an assumption that the cats like each other. Thinking about the maths that was required and what could be used. So mothering kittens, do we define a kitten as a cat? So we assume that they could be large or small. And then you could show them this picture, which is depending on, of course, how the cat is lying, how much room they're taking up. Now, this actually, the more I look at this problem, the more interesting it becomes, because you've got an assumption, again, as Anne says, do they lie on top of each other, and how many could you fit on top of each other peacefully? When you think about a cat, there's a lot of fur there, and you think about overlap. You could do this just mathematically. You could apply areas. You could say, what's the optimum shape for the cat to be in so that you can fit lots on there. You could grid up your chair and say, what area is the cat? If I could cut my cat up into little bits and fit them all on the little different parts of the chair, how many cats theoretically could I fit on their chair? So there's a lot of options for you to take this from something quite simple into something a bit more complicated. Yeah, wet them, so give them a wash first, as Anne said. This one, how long will it take to spread gravel from a stockpile onto a track? And this is a real thing that we had to do. We have a lot of working bees at our school, and students get involved also with some afternoon sessions, sort of native nursery type sessions. So we had a lot of gravel that needed to be spread onto the track beyond here, and there was a need to estimate how long this was going to take. So it was more than a few hours. I got a student to do this as part of an assessment, and he estimated it would be around about a week for one student. Yeah, there was a lot of gravel there. So lots of possibilities for actually going out and trying it, estimating the volume by various means, physically loading up a wheelbarrow, timing how long that took, measuring how much was in one wheelbarrow, or estimating that, and then looking at average travel distance, therefore average travel time, and then thinking about how much more quickly could that be with a group of people, because sometimes you lose efficiency as you have too many people. This one here is one that I've done as an assessment, as a collaborative and individual hybrid. So they start off working together and then have to write their report individually in a supervised session. The model cars queuing at a fast food drive-in. If you've got a set wait time that you give them, and that the arrival rate depends on how many cars are in the queue. So you end up with sort of a self-adjusting situation that longer queues are less attractive, so you get fewer cars that arrive. So this is a really interesting problem to do as an iterative solution. And again, they need to state some assumptions, but quite a lot of information is given to them. E-scooters. I trained a team at Roskell, and it's great to see Kailash Ranchoti here. Thanks for joining, Kailash. We had a couple of teams at Roskell a few years ago that did really well. And one of them represented New Zealand in the International Mathematical Modelling Challenge that Kerry supervises or organises for New Zealand, and that team ended up placing in the top 8 in the world, which was awesome. But we trained for about a month on this problem: how many e-scooters should be placed in a suburb, and where should you put them? So you can do demographics on the suburb. You can give them information on who lives there and what types of uses might they have for a scooter, whether they might be traveling to work, to university, to a local school. And you can look geographically or statistically or a combination of those things to come up with your solutions. And just lastly, a few other examples that you could think of that might be relevant and that we've done some work on. Now, just thinking about next steps here, there's a few difficulties in that we don't feel that we are necessarily rewarded with an achievement objective in NCEA, although there is one in the New Zealand Certificate of Steiner Education. So that's a bit of a demotivator. There are voluntary options that students can participate in these competitions, but we do need professional development for teachers, for those who are keen to get this going. So just wanted to hand this over for the next couple of minutes to Kerry, who has been putting a proposal together, and unfortunately it sounds like the funding isn't available this year, but we've got some other initiatives there for running out some pilot projects in schools.
Awesome. Thank you very much, Roland. Thank you very much for, I know that you haven't finished yet, but a great presentation. I mean, you gave a really good showcase of the literature, said some of the stuff that more succinctly than I could. And I mean, all your examples are just like the drawing, because one of the key things with modelling is that you want to use examples that come from the students' world so they can relate to, and you've just showcased and shared with us just a really, really rich lot of examples. So I want to thank you very much on behalf of the community for that as well too. So just talking about some like PD opportunities and stuff. Like my work is in the area of mathematical modeling education, in particular, actually looking at it for secondary students and also in the tertiary space. But within the tertiary space, we're trying to get some funding for a TLRI project, which is about actually bringing together teachers that are interested in learning how to develop modeling units based on the holistic modeling cycle, i.e. that top-down approach. Roelant is definitely part of this project as well. And but we're trying to get funding for that. So of course there's going to be that coming up if anybody's interested, and I'll put my email in the chat to just drop a line, because the idea is to work alongside you, pick a particular issue that's really relevant to your community, and then design a whole unit plan based around using the holistic mathematical modeling cycle to get some information about that you can use to help alleviate change. And we did it, me and a colleague have already piloted this out with Manurewa High School. I don't know if anybody has seen my presentation. I think I did it at NZAND a couple of years ago. We actually looked at affordable housing with the students. We used the modelling process for them to really be able to identify some of those key things that were important to them as a community, as the young for the future. And then we got them in front of the Auckland Council, and they presented those findings to Auckland Council. So it was incredibly empowering for those students. So not only did they get to see that mathematics was useful and that mathematics was useful, but it can also be a way of being able to provide evidence for supporting some of the things that you would like to see put in place in your local community. So another really good opportunity for teachers, because I know one of the drawbacks for us as teachers can be that sometimes we just don't feel confident in what modelling is. And Roland's given you, Roland, you've been amazing at what you've shown today. So hopefully to take away some of that fear. But one of the things you can do is every year, MINS, it's called Maths and Industry New Zealand, and normally happens around the school holidays in the middle of the year at the moment, around July. They hold a situation where what happens is that 7 problems from industry actually are presented to a group of mathematicians, engineers, and you as school teachers are also able to participate. You just put your hand up, you just register. It's free registration, and then you get to go into the MINS environment, be part of a modelling team, choose which problem from industry you want to work on, and actually be part of a real world modelling team. So you actually get to experience so you actually get to experience what it is to like to be a modeler. The fact that you don't always have to have all the solutions, you've got other people that you work with, and that's a really good opportunity for you yourself. And again, I run the International Mathematical Modelling Competition, which happens every year. The call out for that comes at the beginning of the year. It's a 5-day event, and I'll be talking a little bit more on that at the Maths and Calc Day at AMA. And I suppose I can talk for a long time. So what I'm going to finish with is that I'm also presenting at Maths and Calc Day on the Friday 22nd, also on how to facilitate modelling in the classroom, and also we'll give some more information about IMMC. And what I'm going to suggest, Roland, is that we participate, is that we make sure that your session and my session are not on at the same time, so that we can get as many people involved in thinking about modelling as a practice and how we can implement it in schools. And the good news, and Cami will probably be able to comment on this even further, is that we do have one achievement standard in the NCA, one of the new ones, and it basically states this. It's a level 1 assessment 1.1. Students are able to use mathematical methods to explore problems that relate to life in Aotearoa, New Zealand, or the Pacific. So that is an opportunity where you can put modelling in practice in your classroom.
Oh, that's awesome. That's awesome.
Yeah. So sorry, that was a whole lot of me just dumping, but hopefully that's given you a really, really quick run over of what opportunities there are out there to further grow in this. And I'll hand back to you, Roland.
Yeah, pretty much done, but just wanted to add in there that I'm aware that there's some work being done on a mathematical modelling cycle similar to PPDAC. And I see Cami's in the session. I do remember, Cami, you talking about that at some point. So it'd be great to hear a bit more about how that's progressing. I will put into the chat, well, my slides, these slides, if you want to see them, have been uploaded to the AMA website. So you're welcome to look at those. But just to close off, as a summary, modelling has its own skills. They do need to be developed, and they do take time. And there's a couple of approaches. Either is appropriate, but they've got different objectives. And we can stage it, we can design them carefully to match the students, and use prompts that help those who are particularly anxious, particularly students like those with some autism who can get overwhelmed easily. But it's all worth it. So thanks very much. I'm happy to stay on afterwards if anyone wanted to talk a bit more.
Cool. We'll just close the session off, Roland, because you're up last. You're at the very final session this morning, so we'll just close that off. And I'm just going to take over sharing the screen and get something else up. Sorry.
Actually, and just before you do that, I'll just formally thank Roelant as well. So Roelant, thank you very, very much. That was an absolutely excellent session. Really, really useful for teachers. It's really, really good. And I suppose that one way that, that people could, I don't know. And I'm quite happy to stay on for another 10, 15 minutes. And if anybody wants to ask any questions of Roelant and close off and do the fight if you've got me as co-host, I'm quite happy to do that. But we can formally close if we want to with the AMA Kia ora kia, but someone else will need to say it instead of me. Otherwise, I'll close with a different one.
Oh, you close with it. What your one, Kerry?
Okay, sounds good. Māori oho, Māori tū, Māori ora ki a tātou katoa, haumi e, hui e, tai ki e. There we go. Thank you very much. And honestly, people, if you want to ask questions to Roelant, use the chat. I think we've got the hands up button. Turn on your camera and just fire away.
Yeah, and just one more thing. If you want to see more of Roelant and Kerry, there's the Stats Teachers Day, which I'm not sure that you're at, but the Maths and Calc Teachers Day at AUT, definitely that will be another opportunity for you to have a chat with these two people that know and love mathematical modelling, which is awesome. Thank you so much.